Imagine holding the vastness of a mountain range in the palm of your hand. Topographical maps, unlike their road map cousins, offer this incredible ability. They are the trusted companions of hikers, adventurers, and anyone seeking to understand the lay of the land. These maps are more than just guides. They are intricate portraits of Earth's surface, translating the complexities of three-dimensional landscapes into a two-dimensional format. They unlock a deeper understanding of our planet's topography, revealing the hidden language of hills, valleys, and everything in between. These maps are essential tools for a wide range of activities, from planning hiking routes and understanding water flow to analyzing potential construction sites and predicting avalanche risks. They empower us to make informed decisions in outdoor pursuits and various professional fields. By learning to read these maps, we equip ourselves with the knowledge to navigate unfamiliar terrains, anticipate challenges, and appreciate the intricate beauty of our planet's surface. Topographical maps are renowned for their use of color, but these hues serve a far greater purpose than mere aesthetics. They are the key to unlocking the map's vertical dimension elevation. Each color, carefully chosen and standardized, represents a specific elevation range. This standardized color system allows for quick and easy identification of different landforms and their relative heights. Typically, shades of green depict lower elevations, often indicating valleys, plains, and lowlands. As the elevation increases, the colors transition to yellows and browns, representing hills and rising terrain. Higher elevations, such as mountains and plateaus, are often depicted in shades of red, brown, and sometimes even white for the highest peaks with snowcaps. Understanding this color-coded language is crucial for comprehending the map's representation of the Earth's surface. A crucial element of understanding topographical maps lies in grasping the concept of scale. Scale is the ratio between the distance on the map and the corresponding distance on the ground. It acts as a bridge between the miniaturized world of the map and the real-world distances we experience. For instance, a scale of 1 to 50,000 indicates that one unit of measurement on the map represents 50,000 units on the ground. This understanding is essential for accurately interpreting distances, planning routes, and estimating travel times. Most topographical maps clearly display their scale, often in multiple formats, a ratio, for example, 1 to 24,000, a verbal statement, for example, 1 inch equals 1 mile, or a graphic scale, a bar with markings indicating real-world distances. By applying the map's scale, we can translate the seemingly small distances on paper into the actual distances we would cover on foot or by vehicle. Armed with an understanding of scale, we can now delve into the practical aspect of measuring distances on topographical maps. There are several methods, each with its own advantages depending on the terrain and the level of accuracy required. The simplest method involves using a ruler to measure the straight-line distance between 2 points on the map, and then converting that measurement to real-world distance using the map's scale. However, for routes that meander along winding paths or across uneven terrain, a more accurate method is the thread method. This technique involves laying a piece of thread along the desired route on the map, carefully following its curves and contours. After marking the thread's length, corresponding to the route, the thread is straightened out and measured against the map's scale to determine the actual distance. This method provides a more precise measurement, especially for routes that deviate significantly from straight lines. One of the most distinctive and crucial features of topographical maps is the network of fine lines that gracefully traverse their surface contour lines. These lines are far more than just abstract markings. They are the map's way of conveying the shape and elevation of the terrain. Each contour line represents a specific elevation above sea level. When these lines are close together, they indicate a steep slope as the elevation changes rapidly over a short horizontal distance. Conversely, contour lines spaced farther apart represent gentler slopes. Closed contour lines forming concentric circles or ovals indicate hills or summits, with the innermost circle marking the highest point. Contour lines are the language of topographical maps, and learning to read them is akin to unlocking a secret code that reveals the hidden shapes of the landscape. While contour lines provide a comprehensive overview of elevation changes, topographical maps often include additional elevation information in the form of spot elevations. These are numerical values printed directly on the map, representing the exact elevation of specific points. These points are typically chosen for their prominence or significance, such as mountain summits, lake surfaces, or road intersections. Spot elevations provide valuable supplementary information, allowing for precise determination of elevation at specific locations. They are particularly useful for pinpointing the highest points, estimating the depth of depressions, or determining the elevation difference between 2 points not connected by a single contour line. By combining spot elevations with contour line interpretation, we gain a more complete and nuanced understanding of the terrain's vertical dimension. Mastering topographical maps involves integrating the various elements we've discussed, understanding scale, decoding color-coded elevation, measuring distances, and interpreting contour lines and spot elevations. Each element contributes to a comprehensive understanding of the landscape depicted on the map. Imagine planning a hike through a mountainous region. You would use the map's scale to estimate the distance and time required for your journey. The contour lines would reveal the steepness of the terrain, helping you anticipate challenging ascents or descents. Color-coded elevations would provide a quick overview of the elevation gain and loss throughout your route. Spot elevations would pinpoint the exact height of peaks or passes, aiding in navigation and decision-making. The knowledge gained from reading topographical maps extends far beyond the realm of hiking and outdoor adventures. These maps are invaluable tools in various fields, including environmental science, where they are used for analyzing watersheds, predicting erosion patterns, and studying wildlife habitats. Engineering and construction for assessing site suitability, planning infrastructure projects, and mitigating environmental impact. Emergency management in planning evacuation routes, predicting flood zones, and coordinating disaster relief efforts. And urban planning, analyzing land use, designing parks and green spaces, and understanding urban development patterns. In each of these applications, topographical maps provide a crucial understanding of the Earth's surface, enabling informed decision-making and effective problem-solving. Topographical maps are more than just tools. They are gateways to exploration, understanding, and appreciation for the natural world. By learning to read their language, we embark on a journey of discovery, uncovering the hidden stories etched into the Earth's surface. Like any new skill, mastering topographical maps requires practice and patience. Start with simple maps, gradually progressing to more complex terrains. Use online resources and tutorials to supplement your learning. Most importantly, venture out into the field with your map in hand, putting your newfound knowledge into practice. As you navigate unfamiliar landscapes, you'll find that each successful interpretation, each correctly identified landmark brings a sense of accomplishment and deepens your connection with the world around you. So embrace the world of topographical maps and let them guide you on your own personal journeys of exploration and discovery.